In this lesson, we will learn how to solve a system of linear equations with 3 equations and 3 variables.
Alright, let's get started. There are 3 types of outcome that can happen. First, we can obtain one solution, which is an ordered triple with x, y, and z. Second, we can have no solution, which is when a number is not equal to another number. Third, we can have infinite many solutions, which is when a number is equal to another number. Remember, one solution means 3 lines intersect at one point. No solution means there is nowhere the 3 lines intersect. Infinite many solution means the 3 lines are actually the same line, so they touch infinitely. There is a general flow on how to solve system of linear equation. We will be given 3 equations, 3 variables. First, we have to try to eliminate one variable. It can be x, y, or z. We will use elimination to eliminate the variable, and we have to do it twice. So we should get 2 equations with 2 variables left. Then we will use elimination or substitution again to eliminate one of the variables to obtain a solution of one variable at the end. Then we will use that variable to plug back into our previous equation that has 2 variables to solve for the other variable. And lastly, we will plug in those 2 variables that we got and plug it back to our very original equation. It could be either one of the 3 to obtain our very last variable. This is the general flow of solving a system of linear equation with 3 variables. But before we go into an example, there are 2 rules that we should know. Rule number 1, we can multiply the whole equation by any number. Rule number 2, we can either add or subtract the equations from one another. So let's take a look at an example. X plus 2y minus z equals 4. Let's name this equation A. 2x plus y plus z is equal to -2. Let's name this one B. X plus 2y plus z equals 2. Let's name this equation C. So 3 equations, 3 variables. First, we have to target a variable to eliminate. So you can either choose x, y, or z. It doesn't actually matter. Make sure you are consistent when you eliminate. In this case, why don't we choose x? How can we eliminate x from the equations? What you are going to do is you will pick 2 equations and try to eliminate the variable x. In this case, why don't we pick equation A and equation B? Equation A has x, equation B has 2x. How can we eliminate the x? Remember, rule number 1 allows us to multiply any equation with any number. So why don't we multiply equation A by -2 and add it to equation B? If we do -2 times equation A, we will get -2x minus 4y plus 2z equals -8. All we did was to multiply equation A by -2. And that's added with equation B, which is plus 2x plus y plus z equals -2. If we combine them, the x will cancel out. We will have -3y plus 3z equals -10. Now we have successfully eliminated one of the variable and obtain an equation with only 2 variables. We will need to repeat that process again with 2 different equations. So why don't we try equation B and equation C? How can we eliminate the x? What if we multiply equation C with -2 and add it to equation B? Multiplying -2 to equation C, we get -2x minus 4y minus 2z equals -4. And we add equation B, which is plus 2x plus y plus z equals -2. Combine them, we get the x cancels out, -3y minus z equals -6. Now we have successfully get another equation with 2 variables. Remember, you have to eliminate the same variable. So we will name the first equation, equation D, and the second equation, equation E. And now we follow the flow chart, we should see that we have to either use elimination or substitution to solve for one variable. Let's copy the equation over. We have negative 3y plus 3z equals negative 10. Negative 3y minus z equals negative 6. If we use elimination again, we can either choose to eliminate y or eliminate z. In this case, eliminating y is easier. But how can we do that? All we have to do is multiply one of the equation by negative 1. So why don't we multiply the first equation by negative 1 and add it to the second equation? We will get 3y minus 3z equals 10. And then add it to negative 3y minus z equals negative 6. So the y will cancel out and we get negative 4z is equal to 4. Z is equal to negative 1. Now we have successfully obtained one of the variable. All we have to do is plug it back to the equation that has two variables and solve for the other variable. Why don't we choose equation D? It actually does not matter which equation you choose. So we have negative 3y plus 3 times negative 1 equals negative 10. Negative 3y minus 3 equals negative 10. Add 3 on both sides, we get negative 3y equals negative 7. Divide both sides by negative 3, y is equal to 7 over 3. And now we have obtained another variable. All we have to do last is plug the two variables we got back into either one of the equations at the beginning. It does not matter which one we plug in. So why don't we try the first equation? X plus 2 times 7 over 3 minus negative 1 is equal to 4. X plus 14 over 3 plus 1 equals 4. Subtract 1 on both sides. We get x plus 14 over 3 equals 3. And then we do a change of base. 3 is the same as 9 over 3. We're going to subtract 14 over 3 on both sides. And we will get x is equal to negative 5 over 3. Lastly, all we have to do is to put them into a order triple, which is negative 5 over 3, comma, 7 over 3, comma, negative 1. This represents a point where all three lines intersects. In summary, to solve a system of linear equation with three equations and three variables, all we have to do is target one variable and use elimination to eliminate that variable. But we have to do it twice using two different equations. That way, we will obtain two equations and two variables. Then we will use elimination or substitution to solve for one variable. Once we obtain the answer for a variable, all we have to do is plug it back to the two variable equation and solve for the other variable. Once we obtain two answers for variable, all we have to do is plug into either one of the three at the very beginning to solve for the last variable. And at the end, make sure to put it into a order triple, which is x, comma, y, comma, z. And it represents a coordinate. And this is how you will solve a system of linear equation. In our next lesson, we will go over the outcome for no solution and infinite many solution.
If you guys like that content, please feel free to smash that subscribe button and help support the channel.